In this video, we'll talk about Linux firewalls. Specifically, we'll talk about IPTables, which is a front end to the NetFilter add-on, which is a kernel-level firewall that's used in Linux. We'll look at the syntax of firewalls, specifically IPTables. We will look at how to optimize firewalls, what firewall rules should look like, and finally we'll do a demonstration with 3 host-only based networks, specifically 3 versions of Linux running, and we'll set up the firewalls on one Linux as a server, and we'll see if our rules will actually allow us to connect or deny connection to that server. So IPTables is actually software, and it's really an interface. And it's an interface to the NetFilter firewall that is built into the Linux kernel. And there were previous versions of IPTables that were called IPChains, which is in the 2.2 kernel, and IPFadmin, but those have been superseded by IPTables. And so essentially, IPTables provides an administrator with a simple interface that can be used to add, remove, or modify packet rules. And for more information about NetFilter, you can go to www.netfilter.org. So before we go in depth into IPTables, let's look at default types of policies that you might want to apply to the incoming packets on your network. So here we have one called a deny everything by default policy. So here we have an IP packet coming into the network. It hits the firewall chain, and then we have our rules. And so the IP packet coming in is matched against the first rule. If it matches, we accept that packet and we move it on to its final destination. If it doesn't match, it goes to rule 2. And now rule 2 is matched against the contents of the IP packet. If that matches, that's accepted. If it doesn't, it goes to rule 3, and so on. Notice here that the default policy is to deny, and that is, if no firewall rules are matched, then we deny the IP packet's access to its final destination. On the other hand, we can have an accept everything by default policy. Here we have the same scenario, but notice the difference between the 2 types of policies. The IP packet comes into the firewall chain, it's matched against rule 1. If it does match, we deny that packet access to the network. If it doesn't match, we go on to rule 2. If it matches, yes, we deny it, and so on through rule 3. If the packet doesn't match any of the rules in our firewall set, then we accept that packet. Now, what are the potential problems with each of these types of policy? Well, with the not accept everything by default policy, if we happen to miss a critical firewall rule that we should have added in here, then a malicious packet would be able to traverse the firewall chain and be accepted into the network. So we have to make very sure that we have every single rule that we need to have in order to allow only non-malicious packets into the network. Now think for a second, what would be the possible negative consequences of having a deny everything by default policy? If in our rules we happen to miss something critical, let's say for example we want the ability to have some clients on the network to be able to access an FTP server. If we don't include that rule, then they will be denied access to the server, which can cause consternation on the clients. But also, essentially, what you've set up is a denial of service on the clients. So you have to be careful in both situations to make sure you have the necessary rules to allow access to those resources that are required by valid users on the network. So which is best? Well, it really depends on what you're trying to do. So it depends upon the context and the circumstances of the organization and its policies. So NetFilter is really a packet filtering firewall. And it can do several things. The first thing is it can protect against source address spoofing. We'll see that just momentarily. It's useful information revealed in response to port scans. It can identify malformed broadcast packets that are used to identify Unix systems. A lot of times we don't want to provide for the intruder or bad guy the fact that whether we're using a Windows system or a Unix system. Might want to filter those packets so that the intruder doesn't know what type of system, because it then gives them intelligence about what to target. It protects against some forms of network mapping, some denial of service attacks, we'll see shortly, source routed packets, which is different from traditional routing, but because source routed packets indicate within the IP portion of the packet the exact route that a packet should take rather than letting the routers handle that information. Some forms of fragmentation bombs, that is, when an internet packet is fragmented on purpose, it can actually set up a situation where there's a denial of service attack if it's done on purpose. It can also protect against local mistakes that may affect a remote site, and it can control access to private LAN services. IPTables now comes with new features with respect to packet filtering, including the ability to use source and destination port lists. It gives it access to the TCP state flags, SYN, ACK, reset, push, urgent, fin, and so on. Access to the TCP options field. Connection state maintenance for TCP, UDP, and ICMP exchanges, and this will be important in creating our stateful packet filtering firewall, which we will do. It also provides access to the IP header fields as well as the MAC source address, which means that we can filter according to the media access control or hardware network interface card source address with our packet filter. And this is one of the types of attacks. It's a denial of service attack that packet filtering firewall can mitigate. Here you have the attacker over here. Here you have the server. And what the attacker does is sends a stream of SYN packets in rapid succession to a particular port, let's say port 80, so they're running a web server on this computer. And recall that once the SYN packet comes in, that the destination here will send back a SYN ACK, and then we'll wait for the final ACK to create the three-way handshake. Well, if these SYN packets are sent and no responding ACK is ever sent, that causes an overload and a denial of service attack here, because this can only hold so many connections at one time, waiting for the final ACK to be responded to. Another type of protection afforded by the NetFilter firewall is a ping flood, and this is called a smurf attack. Here we have the attacker and we have the victim. The attacker sends a ping echo request to the broadcast address of the network on which this victim resides. However, the victim has spoofed the source address here to be the destination address, which means that this broadcast ping echo request goes out to all the computers on the network, and then all those computers reply back to this victim due to the victim spoofed address being the destination address, causing a denial of service attack. The IPTables has a standardized and a very simple syntax. IPTables -- flush, which means to flush all the firewall rules that are already uploaded into the kernel. We could type IPTables and then -a. -a means to append. -a input means to append to the input chain, that is, looking at all the incoming packets from the network. -i stands for the interface. In this instance, we're looking at the loopback interface. Is used for inter-process communications within the computer. And so those are going to be necessary. And so here, incoming on loopback, and -j is called the target. And the target here is to accept these packets. So anything incoming on the loopback address should be accepted. Our next rule says IPTables append to the output chain, to the outgoing interface loopback, which means that there's inter-process communication between the input and the output on the loopback interface, and we want to accept those as well. And we should always do this. I don't know of an occasion where you'd want to deny loopback access, so you would always want to have these rules in your set of firewall rules. And finally, we can identify our default policy. Here, we've got three policies, three firewall rules. The first is the policy, the default policy for the incoming packets, and that is to drop them. So we're looking at a default deny everything policy. This rule defines a policy for the outgoing packets, and that is to not deny everything that's going out. And finally, the forward rule is only necessary if you have two network interface cards and you're taking the input from one network interface card and forwarding it to another interface card for processing. And there are three important IPTables targets. Accept means to let the packet through. Drop means to drop the packet quietly. That is, don't do anything with it, just drop it and do not respond to the incoming packet. Finally, we have reject, and some people get these confused, but they're handled differently. Reject means you essentially don't do anything with the packet, but you do return an ICMP port unreachable or other ICMP message to indicate back to the source computer that that port cannot be reached. So what would be the difference between these two in terms of security? Well, let's say somebody's trying to connect to our SSH server over port 22. If we don't want anybody to know that we're running SSH, we could use the drop as the target, which means that the intruder would never receive any packets back indicating whether the port is opened or not. However, if we used reject, that would tell the intruder that that port is up but is unreachable, which could give the intruder some intelligence with respect to the kinds of services that we're running on our computer. So there's consequences in terms of security as to whether we want to use drop or whether we use reject for incoming packets that we don't want to process into our network. So let's look at our first simple example. Here in our firewall rules, we've defined our server IP as 192.168.0.3. So essentially, the server IP is a variable. And the reason we want to do this is if we ever change the server's IP address, we can just simply change it one place at the top of the rules, right here, and then anytime we refer to it later, this value will be replaced where we ever see server IP. So it's just like coding with variables. So here what we're doing is we're dropping all FTP requests. So IPTables -I, that's the input. So -I means to insert the rule into the input chain. -i means the interface. Here it's ETH0. -p stands for the protocol, and here TCP because FTP runs over TCP. -s stands for the source address. Notice here we've got 0/0. That essentially means any source IP address. -d stands for the destination address, and notice that we have a $sign prepended to server IP. So when NetFilter sees this, it's going to evaluate server IP as 192.168.0.3. Notice here we have a --. Anytime we have a single letter indicating a parameter in a firewall rule, we use a single letter, we can use a single dash. If we use the longer version that's more than one character, we have to use a --. So it's -- destination port 21, the target is to drop. So what this says is any incoming packet that's coming into our ETH0 network interface card, that's a TCP packet that's coming from anywhere, and the destination address is this address on port 21, we want to drop it. So now let's look at how we would handle SSH connections. So here we have IPTables. We want to insert the rule on the input chain for the interface ETH0 for packets that are TCP, sources coming from anywhere, to the destination server IP on the destination port 22, which is SSH, -j, the target is to accept that packet. Now let's say we want to limit access to SSH to only computers on the same network. What we can do is we can define a new variable called network. And so our new definition is 192.168.0.0/24 in CIDR notation. And then we can change the above rule to this. So insert on the input chain on the interface ETH0 packets that are of TCP, and the source is coming from our network, that is our internal private class C network, to the destination server IP address, to the destination port 22 SSH, is to accept it. So here what we've done is we've limited access to SSH to only clients with this source address. Now let's look at something a little different, where we're going to allow incoming ping client requests. So in this case, IPTables insert on the input chain for the interface ETH0. Notice now our protocol is ICMP. We also must specify an ICMP type, because there's actually 8 different types. ICMP type 8 is an echo request. So essentially that's a ping. -S, the source address is anybody. -D is our destination server. Notice we've added something new here. The -M state and the -state, new, established, and related. Recall that we talked about a stateful packet filtering firewall. What we're doing here by adding the -M state and the -state, new, established, or related, says that this is valid for all new connections or whether they're established and related. Established and related means that they're going to be in the connections table for existing, already established and related connections. And so this indicates that we should accept the packets that are asking for an ICMP echo request from anybody, whether it's in a new connection or whether it's an established and related connection. If we're going to allow outgoing pings, we have to obviously also have a firewall rule that will allow for incoming responses. And so we do that here. Here we're inserting on the output chain for the interface ETH0. The protocol is ICMP. The ICMP type is 0, and 0 is echo reply. -S, notice now, is the server IP. Notice now that the source address is the server IP, because the source is going to be sending the echo replies back to the destination computer. Notice the -D here is 0/0, meaning anything. The -M state and the -state, established and related, means that now only previously established and related connections that are in our connections table for our stateful packet filtering firewall, will that packet be accepted for egress packets, that is, packets outgoing from our network. If we would like to disable all outgoing ICMP requests, we can do it one of 2 ways. We can notice here here, rather than inserting a rule at the beginning of the firewall rules, we're going to append to the last firewall chain the output chain for any packets that have a protocol of ICMP with an ICMP type echo request. We're going to drop that packet, which means there can be no outgoing echo request. So what don't we have here? We have no source address nor destination address, and it really doesn't matter, because what we're saying here is that there's no ICMP echo requests that are going to be allowed outgoing on the output chain, so they're all dropped. Alternatively, we can use the same syntax here, but instead of saying echo request, we can just say include the number 8, which is a code type of echo request, and we're going to drop that packet. So that's a very simple way to drop all outgoing ICMP requests. Let's say we wanted to change this rule so that it would drop all incoming requests. How would we change this? The only thing we need to change is to change this output to input. And again, we would only need one of these rules. So it would be IPTables-A input, and then the same syntax. Recall again that we talked about stateful packet inspection, which means that once a packet leaves and establishes its three-way handshake in a connection, that information is kept in a stateful filter table, and saw all related and established packets that come in or out of the network that are included in that stateful table won't need to be matched against all the firewall rules, which takes time, of course. The more firewall rules you have to be matched by a packet, the longer it takes for that package to get to its destination. So here what we're doing is we're adding a statefulness to our firewall. So the policy IPTables append to the input chain -m state --state established and related and accepted. So anything that's already established, any packet that's part of an established and related connection that's in the stateful table will be allowed through the network. And of course you'd want the same rule for the output chain, obviously. A simple standalone set of firewall rules. First, let's identify our variables. Server IP, and typically you would do this just in case that the server IP might change at some point in time. Otherwise, you'd have to go through your firewall rules and change every instance of this. And if you've ever coded and not used variables and instead uses the actual values, you know what a problem that can be. Notice that we're indicating our interface. We're calling it internet here, ETH0, and it doesn't matter what you call it over here as long as you use it consistently throughout your firewall rules. We've got an ETH0, single network interface. The loopback interface is LO. Here we're referring to our actual network, so the subnet base is 192.168.0/24. Notice that our loopback is going to be our typical loopback interface network CIDR notation. And notice here we've also got private networks, class A, B, C, D, and E. Why would we identify private network addresses? Because let's say if we're using a router at the edge of the network and we see any of these addresses being routed over the network into our network, we know that these are spoofed addresses because these are unroutable addresses because they're private, and therefore the router shouldn't be seeing them, and if it does, it should be dropping those packets. So let's continue. And so we've got IPTables -- and that should be a -- luckily when you do this in PowerPoint, a -- turns into a single long dash. Thank you, PowerPoint. So this says we're going to flush our rules. Then we want to create unlimited traffic on our loopback interface. We'll always need to add this, and we'll add this up front because we want this to be processed very quickly. So on our input chain for the loopback interface, except for the output loopback, the target is accept. Then we define our default policies, and it is to drop in this instance. Recall that drop means that the packet is gracefully and quietly dropped, and no packet is sent back to the requesting client computer. And then up front we want to make sure that we include our stateful packet inspection, which we've just gone over. So we have a stateful rule for the input chain and a stateful rule for the output chain for established and related connections. And then we want to check on source address spoofing and other bad addresses I just discussed previously. So here we're appending to the input chain for our ETH0, if you recall that was ETH0, and for the source address, our own IP address, we want to drop those because that's essentially a way to cause a denial of service attack, is having a source and destination address that are the same, and you get in this cyclical loop, and it causes a denial of service attack. And then you also want to refuse packets claiming to be from all the private network addresses, the class A, B, and C. So notice here we have our variables class A that was defined previously, class B, class C, and of course the loopback interface coming in over ETH0, because loopback, anything coming over the loopback interface should only be sending packets to other loopback addresses, not to our ETH0 our network interface card address. Now, of course, there are many other firewall rules you'd want to create, but let's stop right there now and let's talk about firewall optimization. What we want to do is we want to make sure that the rules are going to fire or going to be seeing the most traffic. We want to put them as early as possible in the chain because those will be the ones that will need to be processed quickly. So we want to place the loopback rules as early as possible, as we did previously. We want to place forwarding rules as well. In this instance, that would require 2 network interface cards. And we want to use the state and connection tracking, that is the stateful firewall rules modules, to bypass the firewall for established connections. And we also want to use a state and connection tracking, and that relates to a stateful packet filter modules to bypass the firewall for established connections, because if something's already established and related, it's already gone through all the firewall rules. We don't want to have it to traverse the input and output change if it's not necessary. We can also combine rules to standard TCP client server connections into a single rule using port lists, and we'll show you how to do that shortly. And also, we want to place rules for heavy traffic services as early as possible. And here I ask, where would you place stateful packet inspection? Well, we want to place those as early as possible. So let's apply what we've learned thus far with a simple illustration. So we've defined our policies. Our default input policy is to drop. Our default output policy is to accept anything going out unless it's denied by a rule. And finally, even though we're not going to use it, we need to go ahead and define a default policy for forward, and we're going to keep that as drop. We're also going to create a stateful firewall, and we've set up a virtual host network, which I'll show you how to do in another video, but for right now, let's keep it simple. We've got a server. Yeah, and I just changed some of this quickly. So we have 3 computers on this virtual network. We have a server, an Ubuntu server, whose IP address is 1.130. We've got a MIT9 client whose IP is 1.128. And for MIT9, we're going to allow FTP access, and we're also going to allow ICMP requests. And finally, we've got a third computer running Ubuntu 10, whose IP is 1.129. And a little later in the demonstration, I'm going to allow SSH access from the Ubuntu 10, but we're going to reject ICMP requests. So let's see what that looks like. Create rules in any type of text editor or with the VI editor, the visual editor. VI comes with every distribution of Linux, so it's very good to know that, but I'm not going to force you to use that. Of course, you're going to have to use some editor on the server, and you have to do this on the server, by the way. And you can either use Nano, which looks something like this, and it has a helpful little screen down here where you can see what all the key shortcuts are. And if you want to save the file, you type a Control and O for write out. I don't know why they didn't include that as a capital S and save, but anyway, let's exit out of here. But not every computer is going to have Nano. Every computer does have VI. However, I've installed a different package called Vim, which is a modified version of VI, which gives you syntax highlighting. And if you'd like to install that, you type aptitude install Vim. Okay, and I've already done that. So what I've done is I've created a shell script that includes all my IPTables firewall rules. And first we'll go over the rules, and I'll show you how and why I created the script. So we type Vim, and I named this firewall.rules.sh for shell script because this will be an executable. And if you want to see that it's an executable, you'll see right here that it's in green, and notice it has the execute bit set. Normally we don't have the execute bit set for other files because we don't want to execute them. However, for this one we do. And of course you should know how to do that, but just in case you've forgotten from last week, I'll show you how to do that. So Vim, firewall rules, and we see it has a nice bit of syntax highlighting. If you want to take a shell script, create a shell script, you need to first include this line right here that has a number sign and a bang, And then you need to indicate the shell that you want to use to execute this script, which is the bourne shell. So it's number bang or shebang /bin/sh. That's the first thing you need to do to create an executable shell script. I went on ahead and identified the 3 computers on here because actually they were I was having difficulty remember what was what when I was creating the IP addresses down here, so I just went on ahead and I created them as variables. So the server IP is .1130, Mint is 1.128, and Ubuntu is 1.129. So the first thing we need to do in the shell script is to flush the rules, which I've done here on this line. And then we need to identify our policies. We have 3 policies. We have a policy for the input, which is drop, policy for the output, which is accept, and a policy for forward, which is drop, although we won't use this. Just realize that if you don't include this, the policy for forward defaults to accept, which we probably don't want. Then we need to have 2 rules for our loopback interfaces. We need to have for the input for the loopback is accept, and output -O here you see the output interface for loopback is to accept as well. And then let's create a stateful firewall, and so we need 2 rules for that. We need to append to our input chain the -m for state, and the state of the state will be an established and related -j and accept. For our output, we want to append the rule -m state, and the state will be established and accept as well. And we need to change that a little bit. Let's go ahead and do that because that's not exactly correct. Let's click in here. Let's see where we are. This needs to be established instead of establish. Let's go back, type established. Let's write that out. So it's established and related, and we want to accept that. And now this is where we start determining how Mint and Ubuntu can connect to our server. So the first rule in here says IPTables-A, so we're going to append to the input chain for the ETH0 for TCP protocol, and the source is going to be Mint9, which is this IP address. The destination is going to be our server IP, which is this address, and the destination port 21-J accept. So I'm allowing the Mint9 client to connect via FTP. And hopefully I'll remember to show you right after I get out of this that indeed that the FTP server is running. And I'll show you how to do that also, how to add that to your server. Notice here that we have a comment. This number sign indicates that this is commented out. It doesn't mean the same thing as it does here. This actually means something different when you have the shebang right here. But this is a comment. A little later, after we see that that Ubuntu can't connect, we'll take that out and we'll change that rule and just take away the comment so that it can connect. But let's see what it does. So we append to the input chain on the interface ETH0, the protocol TCP. The source address is Ubuntu. The destination address is our server IP, and the destination port is 22, and we want to accept that. But of course, since this rule is commented out, it won't actually be included within the kernel, which means that Ubuntu should not be able to connect to the SSH server. And finally, we have a couple more rules. Let me scroll down here a little bit. 2 ICMP rules. And so we've got IPTables-A append to the input chain for the interface ETH0. The protocol now is ICMP. The ICMP type is 8, or for echo request. And the source is Ubuntu, and the -D for the server IP, and we're going to accept that. And we have one more rule, IPTables-A input chain. We're going to append to -I the interface -P ICMP for the protocol. Once again, we're doing an echo request, and we need to change this right here. Let's see what I've done. I've confused myself. and we need to change this to mint. There we go. We write that out. And so mint 9, we're going to reject ICMP requests to the server IP. Notice this says reject right here. Notice that because the output is to accept that if, for example, if we get an ICMP request here from Ubuntu, it's accepted, then the fact that this is the output is to accept is that we don't need a rule to have the server IP reply to the echo request because the default policy is accept. Okay, let's get out of that. I want you to be careful too when you're looking at this, because notice the spacing in here. The spacing and capitalization is important. Notice that sometimes it's not capitalized and sometimes it is. Some of these keywords need to be capitalized. Whenever you see stuff like this, that means it must be capitalized. Also notice the spacing in here. You need spaces where appropriate, and for example in here there's no spacing between established, the comma, and the related. So try to make sure that your spaces resemble what you see here. Okay, let me get out of here. Write and quit. And the way I made this executable is at first it was a text file, but then I ran chmod and I added the execute bit to everything. So I wanted read, write, execute for me, so that's a 7, and then I wanted execute bit for group and other. Actually, I wanted read and execute for for group, and 1 for other, and then the name of the file, and then that made it executable. Okay, so now let's see netstat-tupan, and I'll show you what's listening. So I've got 21 listening, that's FTP, and I've got 22 listening, and that's SSH. So I've got those two running, and the way I install those was to type sudo aptitude install vsftpd, which allows you to install the FTP daemon for the FTP server, and for SSH, which you should have done already, openssh-server, and you can install that. And after you install it, it automatically starts. So what we need to do now is we need to execute that executable file, and we need to do that as root. And so we type sudo, and because our file is in our current directory, we indicate that it's in our current directory. Firewall.rules.sh. Hit enter. There was no errors. And now what we can do is that we can do sudo IPTables-L for list the rules, and we'll see our rules will be listed, and it might take a little while to show this. I'm not sure why it's taking so long, but anyway, they work. Let's get out of that. Okay, now let's test our firewall rules. Let's go to first let's go to mint 9. Let's move this over a little bit, and recall that mint 9 has capability of connecting to the FTP server. So I want to go to the FTP server .1.130. Okay, and there's the FTP server. I give name PC and my password, and I'm logged in. And there's my files, and that worked. Let's type by. But so what? Maybe IPTables isn't working. Maybe just everything is being accepted. So let's test out connecting to SSH, because there was no rule in there to allow Mint to connect to a SSH. And so let's SSH 192.168.1.130, and that's not going to work. 130. And essentially what's happening is those packets are being dropped. It's not going to connect. Okay, Control C, let's get out of that. Now our Ubuntu system was not allowed to connect to FTP, but it was to, well, not yet to SSH. So let's go ahead and try to connect to FTP. And that's not going to be able to connect either. Because if it was, it would be instantaneous. Let's go back up to server. And let's go back in into Vim in the firewall rules, and let's take out this comment. And so now Ubuntu should be able to connect to our port 22. Save that. And now we need to read the firewall rules back in. And of course the first thing it's going to do is going to flush all the firewall rules and substitute the new ones. Now let's go back over to Ubuntu. Oh, well, I didn't connect to SSH. Well, anyway, you saw I didn't connect to FTP. Nope. SSH 192.168.1.130. And there we go. And it wants my password. And I'm in. Remember also, we were going to allow Ubuntu to ping, but we weren't going to allow Mint to ping. So let's see if we can ping the server. We can. Let's go over to Mint 9. Let's clear that, and let's ping destination port unreachable, which is exactly, look at Vim, go to the bottom, and we have a reject. So that ends this video on IPTables firewall and NetFilter. We showed you how IPTables firewalls work, how you want to set up and optimize your IPTables firewall rules. The syntax, you need to be very careful about the syntax, because if you don't get it exactly right, you will get errors. I would go ahead and create a shell script. It looks just like this. In fact, I'll load this up so you can use that as an example, and you can set up your own little network. I will create another video that shows you how to create your own little host network system so everything is sitting on the same network, and you can do that very easily in VMware.